Now let's just move on further towards a new concept which is called as the trigonometric identities. So what are trigonometric identities? Let us suppose if I'm just talking about a particular equation. So we know that an equation is an identity when it is true for all the values of the variable that are involved. So if I am just comparing the equation being an identity with the trigonometric identity, so we can say that similarly an equation that involves the trigonometric ratios of an angle, they are called as to be the trigonometric identities if it is true for all the values of the angles that are involved. So always remember that the trigonometric identity is actually an equation which involves the trigonometric ratios and they are true for all the values of the angles that are involved. So using this particular definition, let's just find out the trigonometric identities that we can use for this particular chapter. So let us suppose if I am just taking any particular right angled triangle. So if I'm just taking a right angle triangle over here, and this is my right angle triangle and I'm just taking it as nothing but B. Let us suppose I'm calling it as A and I'm just taking this one as nothing but C. So since we know that in a right angled triangle, we know that this is nothing but the hypotenuse, this is perpendicular, this is nothing but the base, and we know that by the Pythagoras theorem, AC square, or let us suppose I'm starting with AB whole square plus of BC whole square is actually nothing but is equal to AC whole square. We definitely know about this concept by the Pythagoras theorem. So let us suppose if I'll write it over here, by the Pythagoras theorem, we know about this particular concept that AB square plus BC square is actually is equal to AC square. Now I am going to deduct the basic trigonometric identities from here. As first of all, let us suppose if I am just dividing AC everywhere in this particular equation. Let us suppose if I am just calling this one as 1. So let's just divide AC whole square everywhere in this particular equation. So if I'll just divide AC whole square over here, this would be nothing but AB whole square by AC whole square plus BC whole square by AC whole square, which is nothing but is equal to AC by AC whole square. So as you can see over here, AC whole square will get cancelled with each other and this value is actually nothing but is equal to 1. So if I'll see over here, then we have AB by AC. Let us suppose if I'll just take the whole square common out of it. So this would be nothing but AB by AC whole square plus of BC by AC whole square, which is nothing but is equal to 1. So we can write this in this particular manner. Let us suppose if I'm just taking this angle A, I am considering this angle A, and using this angle A, I can write AB by AC. Just see this. AB by AC we have, AB by AC we have. So this is my base, this is my hypotenuse, this is the side adjacent to the angle A, this is my hypotenuse. So we can write AB by AC. AB by AC is nothing but is equal to cos of A. So we can write this as nothing but cos of A whole square plus of, we have BC by AC. BC by AC. So BC by AC is actually nothing but is equal to sine of A. So we can write this as nothing but sine of A whole square, which is equal to 1. So actually at the end we are getting a relationship in between the cos and sine, which is nothing but cos A whole square plus sine A whole square, which is nothing but is equal to 1. And that is the equation that we wanted to find out, which involves a trigonometric ratio such that it is true for all the values of the angle A that are involved over here. So this is my first trigonometric identity, that cos square A plus sine square A is nothing but is equal to 1. This is the first trigonometric identity that will help us to solve the further questions that are related with it. So hence you can see from this particular proof that cos square A plus sine square A is actually nothing but is equal to 1, and this value for the angle A, this is true for all 0 to 90 degree, because we know that cos 0 is nothing but 1, sin 0 is nothing but 0. So hence for this particular trigonometric ratios we can involve the angles from 0 to 90 degrees. So hence cos square a plus sin square a is equal to 1 for all the values lying from 0 degree to 90 degree. Hence angle A is from 0 to 90. It is true for all. So this is my first trigonometric identity. Now let's just talk about the second trigonometric identity. So let us suppose again I'm using the very first equation. Now using again the very first equation, we just have to do other some things which are related with this. So let us suppose if I'm just taking this one again, and I do have this as nothing but, let us suppose if I'll write it over here, we have AB whole square plus of BC whole square, which is nothing but AC whole square. So this is our value. So let us suppose if I'll just write it over here, what is tan of A? So I can see tan of A is nothing but BC divided by AB. So we have tan of A is nothing but BC divided by AB. So let us suppose if I'm just dividing this whole equation by AB whole square. Let us suppose in the same manner I'm just dividing this whole equation by AB whole square. So this would be nothing but AB whole square divided by AB whole square divided by AB whole square. So these values get cancelled with each other. This would be nothing but 1 plus, we can write this as BC by AB. Since we know that BC by AB is nothing but tan, so we can write this as tan A whole square, which is nothing but is equal to, we have AC by AB. So you can see all by yourself that AC by AB, AC, we have AC by AB, we have this AC by AB. So this is nothing but, as you can see, let us suppose if I'll just write it over here. Let us suppose if I'm just writing it over here. So since we can see AC by AB, AC, we have AC as nothing but the hypotenuse, and AB is nothing but actually our base. So this is nothing but is equal to, this is nothing but is equal to secant of A. This is nothing but is equal to secant of A. So hence this is nothing but secant A whole square. So this is nothing but the second trigonometric identity, which is all related with an equation involving the trigonometric ratio. So the second is nothing but 1 plus tan square A can be written as is equal to secant square A. So we can write whole square in that manner, that 1 plus tan square A is nothing but is equal to secant square A, and this is nothing but my second trigonometric identity. So since you can see over here that if I'm just talking about the 0 degree angle, if I'm just talking about the 0 degree angle, so we know that secant, we know that tan of 0 degree, let us suppose if I'll write it over here, tan of 0 degree is nothing but is equal to 0, tan of 0 degree is 0, and we know that secant of 0 degree is nothing but is equal to, secant of 0 degree is nothing but is equal to 1. But if we are just talking about tan of 90 degree, so tan of 90 degree is actually undefined, and similarly if we are just talking about secant of 90 degree, so we know that cos of 90 degree is 0. So the reciprocal of 0 by 1 is again undefined. So it means that the second trigonometric identity is actually for all the thetas that are lying from 0 to 90, but 90 value won't be involved. So hence we can write it over here that A would be greater than or equal to 0, but it is less than 90 degree, because we cannot take 90 degree over here, since we know that tan 90 is undefined, secant 90 is undefined, so we cannot take 90 degree over here. But for this one, A is lying from 0 to 90 degree, it is true for all. Now let's just talk about the third one. So in the similar manner, if I'll just divide the whole equation by BC's whole square, then I will get the answer as 1 plus cot square A is equal to cosecant square A. 1 plus cot square A, which is nothing but is equal to cosecant square A. And since you can see over here that 1 plus cot square A is equal to cosecant square A, which means that A is true for, we cannot put 0 degree in cot of A because it would be undefined, and we cannot put 0 degree in cosecant of A because it would be undefined as well. So 0 degree angle won't be involved for this particular trigonometric identity, and hence A is lying from 0 to 90 degrees. So let's just see whether 90 degrees involved or not. Definitely, because tan of 90 degrees undefined because it is 0 by 1, but sorry, it is 1 by 0. But if we are just talking about cot of 90, so cot of 90 is definitely nothing but 0. So we can involve 0, means we can involve 90 degree, but we cannot involve 0. So hence it means that for this particular trigonometric identity, A is lying from 0 to 90 degree, but 0 cannot be involved over here. So this is nothing but all the trigonometric identities. So always remember, cos square A plus sin square A is equal to 1. 1 plus tan square A is nothing but is equal to secant square A. 1 plus cot square A is equal to cosecant square A. This is nothing but called as the trigonometric identities. Now let's just use these trigonometric identities in the question.